There's another style of power factor correction question here. So we have a motor drawn 2 amps at 58.5 watts on 120.5 volt 60 hertz supply. Line current is to be brought to unity. The sides of the capacitor to be connected in parallel would be. Okay, so unity is a unique scenario. Obviously that's hard to achieve in real life, but theoretically we can definitely calculate that. So again, we're going to have our current. This is like a parallel RLC, so we're going to have our current in our power section. So we have our motor, we're going to have our capacitor bank, and we're going to have our total at the end. Okay, so our motor is going to be a triangle again. It's got both resistive and reactive portions. Capacitor just reactive. And I'm even going to draw this total right now. Usually it's a triangle, but I'm just going to draw it as a straight line here in both of these, because if we're at unity, we've basically eliminated any reactive portion. So that means whatever value we have for here, this has to be exactly the same, and then they would cancel out. Okay, so we'll take some of the information given to us. Motor is drawn 2 amps, and it's drawn 58.5 watts. And it has 120 volt supply. Okay, I'm just going to write that down here, 20.5 volts. Okay, so what we want to be able to do is basically work in one section. So whether you want to work in the current section or the power section, either way we're going to have the value that we're going to need to go back up to the microfarad. So if we got to go all the way to the microfarad, I'm just going to work in current because we got to go up to the impedance section of that, get the XC, and then eventually also go and get the microfarad rating of that. So I'm going to work in current. So I'm going to take this value up to here, just using my voltage. So usually it's P is equal to I times E, and I have P and I have E, and I'm looking for I. So I'm just going to rearrange, go power divided by my voltage is going to give me my current. So if I take my 58.5 watts divided by 120.5 volts, I'll get my current. Okay, so 58.5 divided by 120.5, and I get 0.485 amps. So that goes right here, 0.485 amps. Just give me 1 sec. So then I'm going to take this current here, and I can find my reactive portion. So I'll go 2 squared minus 0.485 squared, and then take the square root of that, and I get 1.94 amps here. So if I want to bring this to unity now, I basically just know that this capacitor also has to be 1.94 amps. So now that I have the current and I want to be able to find the microfarad rating, that's what I want to get to, I can find my XC by using Ohm's law. So if I take 120.5 divided by 1.94 amps, I'll get the XC, okay, an ohmic value. So 120.5 divided by 1.94, and I get 62.113 ohms of XC. Now, if I want to get to the microfarad rating, I got to rearrange the capacitive reactance formula, which becomes C is equal to 1 over 2 pi times frequency times XC. So when I supplement the information into there, my C is going to be equal to 1 over 2 times pi times frequency times 62.113. This frequency is 60 hertz. Okay, so this is going to be 60 there. And make sure to put it in brackets. And when I get my final value of C, I go 1 divided by bracket 2 times pi, just times, delete 2 times pi times 60 times 62.113 bracket, and I get a capacitive a capacitance of 0.0000427, or move the decimal over 1, 2, 3, 4, 5, 6. Should be at 42.7 microfarads. Okay, so that's how we get this guy done. Different style of power factor correction, but hopefully that helps with some questions as well.